This is our second video of section 8.4, solving compound inequalities. And now we're going to actually work with inequalities that involve and we're going to solve them first. So first I want you to pretend that you just have one inequality here. Very similar to ones you've seen before. You're going to solve it just like any other inequality, which is really just like solving an equation, but you have to remember if you multiply or divide by a negative number, you do need to flip the inequality sign, and that still holds true. So I'm going to subtract 4 from both sides, and I get x is greater than negative 3. So I can put this on a number line. Negative 5, negative 4, negative 3. You get the idea. And x greater than negative 3 looks like this. I'm going to have a parenthesis here at negative 3, and we're going to go to the larger side, x greater than. Okay. Now let's pretend that we weren't erasing that one, and we'll actually go ahead and solve that one. So we're going to solve this one totally separately. Again, just the same process that you know how to solve an inequality. I have 3x is now greater than or equal to 6. Divide by 3, I am dividing, but it's not by a negative, so I get x is greater than or equal to 2. Okay? And so I'm going to go ahead and put this on a number line. 0, 1, 2, and so on and so forth. And greater than or equal to 2 looks like this. Okay? But now we want to transpose these and put them both on the same number line. So we know that what we want for this, it has to be an and, meaning we only want the x values that are true for both of these inequalities. So if I put my x greater than negative 3, it looks like this. And my x greater than 2 looks like this, right? But since it has to be true for both, I actually only want, see, this arrow would continue on and would pick up and this follow this arrow and go on forever. I don't actually want this lower part anymore, because if I pick a number, say 0, 0 works for this inequality. 0 plus 4 is 4. 4 is greater than 1. That works. But 0 in this inequality, this becomes 0 minus 5, which is negative 5. Negative 5 is not greater than or equal to 1, so it doesn't actually hold true. So our final inequality looks just like this first one, or the second one here, because those are the only x values that make that a true statement. Oftentimes it will say to solve and write your answer in interval notation. So remember, interval notation for this particular inequality would look like this, since it's only this x greater than or equal to 2 part. So we're going to solve this one. This is a compound inequality. This is another way of writing an and. This is two inequalities here. Essentially, one of them looks like this. Negative 3 is less than or equal to negative 2/3 x plus 5. And negative 2/3 x plus 5 is less than 9. So these are two separate inequalities, but we've put them together as one compound inequality. Now this only works for and inequalities, but when you're dealing with this one, you can just solve it all at once. So I'm trying to get x by itself here. What do I need to do? I need to subtract 5, but when you do that, you need to subtract 5 across both inequalities. Okay, both, or else it doesn't work. This over here, negative 3 minus 5 is negative 8. Less than or equal to, leave your negative 2/3 here, negative 2/3 x, and then that's less than 4. In order to get rid of my negative 2/3, I'm going to multiply by the reciprocal, which is negative 3 halves, and then I have to do that over here as well. Negative 3 halves, negative 3 halves, okay? So then what I'm left with, this becomes just x. Now I multiplied by a negative 3 halves, which means I need to flip my inequality signs. Over here, I get 4 times negative 3, which is negative 12 divided by 2, negative 6. Here I get negative 3 times negative 8, which is positive 24 divided by 2, which is 12. So what this is saying is 12 is greater than or equal to x, which is greater than negative 6. Can you think of a number that works there? A number that is essentially less than or equal to 12, right? Some x, but bigger than negative 6. 2, or 7, or negative 1. The problem with this is that we switched our inequality signs because we multiply by negative, and so this is sort of backwards. Our negatives always go over here on the left, and our smaller numbers, I shouldn't say negatives because they may be positive. Our x will always go in the middle, but if I switch this around, I need to switch my inequality sign back. Similarly with this one, what this is really saying is negative 6 is less than our x value, and then it also has to be, which our x value then has to be less than or equal to 12. Okay, so again, I switched the ends of my numbers, but then I had to flip my inequality signs and put them in the right places. Be careful. This one between the x and the 12 has an equal to. This one between the negative 6 and the x does not. And that needs to still be true in my final answer. So, as an interval, negative 6 and 12, it can equal 12, so that's a square bracket. It cannot equal 6, that's a parenthesis. And then, depending on how you put this on a number line, mine is not exactly perfect, but you can get the idea. Here's my 12, here's my negative 6, and these are going to be connected right there in the middle. Okay, so that's working with compound inequalities with an and, both when they're written as two separate inequalities and when they're written together as one inequality. Okay, we'll see you in the next video.